Good evening. Good evening, everyone. Yeah. Yesterday we were discussing the classification of signals. First classification which we observed is energy and power signal. For an energy signal, we observed the average power is 0. For a power signal, the energy is infinity. All finite length signals are finite amplitude are energy signals. Let us continue the concept of periodic and non-periodic signals. We observed the easiest way to decide periodicity is concept of harmonics. If omega naught is the fundamental frequency, n omega naught indicates nth harmonic of the fundamental frequencies. So whether the signal repeats for integer cycles or non-integer cycles, that is decided by the harmonic concept. Graphically, here I have shown one example, sir. First, we have taken sine wave of 100 Hz, that is first harmonic. 500 Hz means fifth harmonic. When both functions are added, the resultant graph will appear like this. They are repeating, after adding the signals, they are repeating the pattern for 10 milliseconds. Because the common fundamental frequency 100 Hz, such that time period becomes 1 by f naught. 1 by f naught is 0.1 second. Of course, here it is shown as 10 milliseconds. So this is a graphical way of observing that concept. And we observed what is the general time domain condition periodicity continuous case? Xt equals to x of t plus or minus m into t naught, where t naught corresponds to least period of x of t. Whenever we are adding the signals, how to check the common frequency means simply take GCD of the given frequencies. That is a direct technique. Time period is LCM, frequency concept is GCD. So let us see some examples related to discrete concept. Let us see some examples related to discrete concept of periodicity. I'm moving to next slide. Suppose if we have chosen a function like sine 3 pi by 5 n, it is like sine omega naught n form. We want to check whether it is periodic or aperiodic. It is looking like sine omega naught n. Like a continuous signal is periodic for every value of omega naught, the equivalent discrete signals cannot be periodic directly. The periodicity of discrete signal is satisfied if and only if omega naught by 2 pi ratio is a rational number. It is a compulsory requirement. The periodicity of a discrete signal is obeyed if and only if omega naught by 2 pi ratio is a rational number. Why we have to check this condition? Let me explain. The discrete signal periodicity is xn equals to x of n plus capital N, where capital N is the time period of discrete signal. Now we have chosen signal as sine omega naught n. So what is the meaning of x of n plus n? What is the meaning of x of n plus n? Sine a plus b expansion is sin A cos B plus cos A sin B. Here our target is, if these two expressions are equal, then only the periodicity is satisfied. Xn answer must be equals to x of n plus capital N. For that, we should take general solution of cos as 1, sin as 0. Then only both answers are equal. Whenever cos becomes 1, for that frequency sin must be 0 means, what is the general solution we are taking? Multiples of 2 pi. Cos 2 pi 1, sin 2 pi 0, cos 4 pi 1, sin 4 pi 0. General solution is 2 pi m, from which we can say omega naught n equals to 2 pi m. Omega naught by 2 pi is m by n. The respective discrete signal is periodic if and only if omega naught by 2 pi ratio is a rational number. If this condition fails, the respective discrete signal is non-periodic. In our example, what is omega naught, sir? In our example, omega naught is 3 pi by 5 by 2 pi. That becomes 3 by 10. That becomes 3 by. Whatever we got in the denominator is the time period of discrete signal, that is 10 samples. Whatever we got in the denominator is the time period of discrete signal. So what does the numerator m represents here is, to make this discrete signal as periodic of 10 samples, original continuous signal has to repeat 3 full cycles. To make this discrete signal as periodic of 10 samples, original continuous signal has to repeat 3 full cycles. Listen. Just a minute. So the concept is like this, sir. Correct? Sin 3 pi t by 5. This is one cycle. This is second cycle. This is third cycle. In the process of converting continuous to discrete, for every 3 full cycles, we feel 10 samples of repetition. 3 full periods of x of t will cover 10 samples of discrete signal. 3 full periods of x of t will form 1 period of x of n. That will make periodicity of 10 samples. How you will understand that? Only when you take sample form of that one. Anyway, this is unnecessary confusion. Whenever you want to check discrete signal periodicity, what is the definite condition to be obeyed, sir? Omega naught by 2 pi ratio must be rational number m by n. In our example, we got 3 by 10. So blindly, time period of the respective discrete signal is 10 samples. Blindly, time period is 10 samples. Please go through the procedure. Like continuous sinusoid, every discrete sinusoid cannot be periodic unless it holds this condition, sir. Omega naught by 2 pi ratio must be rational number. Continuous sinusoids are periodic for any choice, but equivalent discrete terms are periodic if and only if omega naught by 2 pi ratio is a rational number. That is a definite requirement. I'll give that statement in the next slide. Just go through the procedure. This is first slide, Kartikeya. Just review of what we have done yesterday. Yesterday we solved continuous signals problems with direct logic. What is that? Simply select the GCD of the given frequencies. Discrete sinusoid, just now we started. So what is the point to be observed here is continuous sinusoids. Sinusoid means both sine and cos, and complex sinusoids are periodic for any choice of omega naught. Whereas equivalent discrete terms are periodic if and only if omega naught by 2 pi ratio is a rational number, m by n form. What is the meaning of m and n here? To make capital N as period of discrete signal, m number of full cycles, continuous signal is repeated. In our example, we got the result as 3 by 10 sap. So what is the meaning of 3 and 10 here? 10 is the time period of discrete signal, but to get 10 samples, original discrete signal, original continuous signal has to repeat 3 full cycles. First 3 full cycles, you will observe 10 samples. Next 3 full cycles, another 10 samples. Like that. If the question is given like j power n by 2, sir, j for imaginary, how we adjusted j multiplier in terms of exponential? How we adjusted j multiplier in terms of exponential? E power j pi by 2 n by 2. That is e power j pi by 4 n. E power j omega naught n form. So what is omega naught by 2 pi ratio now? Pi by 4 by 2 pi. Of course, we got rational number, integer by integer form. It is periodic. J multiplier can be adjusted as e power j pi by 2. This is asked in one of the gate paper. Sin pi square n. It is like sin omega naught n only, but omega naught is given as pi square. Sin pi square n. Is it periodic or aperiodic, sir? Directly omega naught is given as pi square. Pi square by 2 pi means irrational. Because pi is simplified as 3.14156 like that. Don't write pi as 22 by 7 to make the answer, sir. Pi is already simplified as 3.14156 like that. Non-periodic. We are expecting integer by integer form. Okay. Here graphically I have shown some curve. Two discrete signals are there. So how to check periodicity here? Omega naught by 2 pi means 2 pi by 12 by 2 pi 1 by 12. So first time it is periodic having 12 samples. Here 12 samples periodicity. Okay. Here also omega naught by 2 pi condition means 8 pi by 31 by 2 pi. So 4 by 31. Again we got m by n style 31 samples. You have to count them. Roughly I have provided the graph here. But last one is non-periodic. Why it is non-periodic? Omega naught by 2 pi ratio now becomes what, sir? Last case 1 by 6 by 2 pi irrational. Non-periodic. First two are periodic functions. Last one non-periodic, no repetition. So these are the graphs. When you take their sample form, sample by sample, if you draw roughly, the graph is going to appear like this, sir. I am going to next slide. Suppose x of n is given as cos 5 pi n by 12 plus sin 4 pi n by 9. Sum of two sinusoids. Think of and respond. Like we have done yesterday, direct logic, sir. Simply GCD of the given frequencies. Simply take GCD. So omega naught is taken as GCD of 3 pi by 12 and 4 pi by 9. What is the common multiplier we can create? 12 and 9 means 36 is a common multiplier. Denominator, if I write 36, what is the adjustment we need for numerator, sir? I multiplied by 3 in the denominator means numerator becomes 15. Here 4 multiplier, so 16. So what is the GCD of 15 pi by 36 and 16 pi by 36? We have 15 pi by 36 and 16 pi by 36. We observed our n omega naught logic. So 15 into pi by 36, 16 into pi by 36. Time period of 72 samples. 2 pi by omega naught means 72 samples. Same as continuous. When multiple discrete sinusoids are added, procedure is same. Simply take GCD of the given frequencies. Sum of step sequence is given, sir. Then you think of u of n plus u minus n. If it is given, periodic or aperiodic? Sum of step sequence. Un added to u minus n. Now it can be periodic or aperiodic. Very good. Non-periodic. Why? Because of the value at 0. Un covers from 0 to infinity. U minus n covers from minus infinity to 0. By adding these two, what will happen? Sample at 0 becomes 2. Rest of all samples are 1. So we lost the periodicity because of the value at origin. We can make this signal as periodic by making which change? The left-sided signal has to stop at -1. Yesterday we studied un plus u minus n minus 1 means 1 for all index. 1 for all. It is having least period of 1 sample, sir. You can make the same signal as periodic by changing u minus n as u minus n minus 1. Okay, moving to next slide. Now you think of -1 whole power n square, sir. -1 whole power n square. What we can say now? Better to draw the signal. Mathematical expression to graph. That is the logic we have. Better to draw the signal. For all even index amplitude is 1. For odd index amplitude is -1. Any even index it is +1, sir. Odd index -1. So it is from the graph, it is alternation of impulses having least period of how many samples? 2 samples. It is alternation of impulses. If it is given like this, sir, of course, no need to write this summation because it is common. summation of del of n minus 3k minus del of n minus 1 minus 3k. Del n is the discrete impulse. Expand the summation and again check the graph, sir. Expand the summation and again check the graph. Suppose we substituted k place minus 1, del of n plus 3 minus del of n plus 2, that is k equals to minus 1. K0 means del n minus del of n minus 1. K value 1 means del of n minus 3 minus del of n minus, like that. Try to expand the summation, because summation ranges from minus infinity to infinity. So if you try the sketch of the signals are del of n plus 3 impulse at minus 3 amplitude 1. Next to del n, del of n minus 1. So we have least periodicity of how many samples? 1 minus 1 0, 1 minus 1 0. Pattern is go on repeating. 1 minus 1 0, 1 minus 1. Least periodicity of 3 samples after sketching the signal. Least periodicity of 3 samples. Okay. Please think of these 3 bits. First bit, a continuous signal is sampled at the rate of 200 Hz. Find the fundamental period of discrete signal. Sampling rate is given as 200 Hz. First you convert continuous to discrete. First you convert continuous to discrete by sampling. Then only you will get the time period of discrete signal. So small t is replaced as what, sir? N into Ts. Small t is replaced as N into Ts. Make it try. Ts is 1 over Fs. Sampling rate is given as 200 Hz. So T place NTS conversion. So what will happen? 2 cos of 150 pi n by 200 plus 30 degrees. That is 2 cos 3 pi by 4. Check for omega naught by 2 pi ratio. 3 pi by 4 by 2 pi means 3 by 8. That becomes m by. We got rational number. Periods D have how many samples? 8 samples. Correct. 8 is correct answer. Suppose we changed sampling rate as 300 heads in the same question, sir. What will happen to the number of samples? If you change sampling rate as 300 heads, then it becomes 150 pi by 300 or not? 150 pi by 300 means pi by 2. Again, verify the same condition. Periods D have 4 samples. Periods D have 4 samples. It means as the sampling rate changes, the number of samples of the signal also changes. By taking 200 heads, we got 8 samples, but for 300 heads, we got just 4 samples. That is what I discussed with you in the first class. Even we are writing xn and x of n minus 1 as the discrete signal. The perfect way of representing that is x of nts and x of nts minus ts. Because once the sampling rate changes, automatically number of samples are also changing, sir. Once sampling rate changes, number of samples are also changing. Second bit, I think everyone will respond. A discrete signal is given as sum of 3 sinusoids there. The term sin 7 pi n corresponds to which harmonic? The given harmonic numbers are 3 pi, 7 pi, 2.5 pi with n omega naught logic. N must be integer. We know integer cycles, but last one is not looking like integer. But 2.5 can be adjusted as 5 pi by 2 or not. 7 pi can be adjusted as 14 pi by 2. 3 pi can be adjusted as 6 pi by 2. Such that what is the common frequency visible, sir? Pi by 2. So sin 7 pi in the question corresponds to which harmonic? 14th harmonic. We want n omega naught logic, n must be integer. So last number 2.5 can be adjusted as 5 pi by 2 such that it will look like 5th harmonic. Try to adjust other 2 frequencies also like multiple of pi by 2, sir. Try to adjust other 2 frequencies also like multiple of pi by 2. Easily we can say the answer. Last bit, for each of the periodic signals shown in figure, evaluate the average value energy in one period, signal power. Of course, signal power means extra 1 by t multiplier, energy for one period into 1 by t. RMS value is square root of power, sir. RMS value is square root of power. See, the time period of first signal is 2 seconds. It is like a full wave rectified sine wave. What is the time period of second signal, sir? We can take 7 seconds. Time period of last one is 5 seconds. First you observe the time period of 3 signal graph. First one 2 seconds, next one 7 seconds, last one 5 seconds. What are the expected quantities? First we want average value. Average value definition is 1 by t integral xt dt. That is the area of the signal over one period by fundamental period. This one we want. Next, energy in one period. That means integral 0 to t mod xt whole square dt. Or if you want to be specific, t naught. Power in the periodic signal means 1 by t naught. RMS value is square root of power. These are the quantities we are expecting for the 3 signals. But our luck is energy for one period. We know we have the predefined formulas. Rectangular pulse energy A square t, triangular pulse A square t by 3, half cycle sinusoid is A square t by 2. Like that we have selected, sir. So no need to perform that integration. But the last signal, how to generate that shape, sir? In signal 3, how to retain that shape? The shape is taken as sum of a rectangle and triangle. The shape is taken as sum of rectangle and triangle. For each of the given signal, we should calculate all these quantities. I am providing answer for you. Later on you check. I am providing answer for you. Later on you check. You also cross check whether average value less than or equals to RMS value. That condition is satisfied or not. In general, average value less than or equals to RMS value. For the 3 signal combinations, you should find out these quantities. Final answer I have given, sir. Okay. So under periodicity, what is a review? What to remember is continuous case cos omega naught t plus theta sin omega naught t plus theta e power plus or minus. They are periodic for any choice of omega naught. But what happened in discrete, sir? Cos omega naught n plus theta sin omega naught n plus theta e power plus or minus j omega naught. They are periodic under which condition? If and only if omega naught by 2 pi ratio is a rational number, that is compulsory, discrete. Either in continuous or discrete. How to check added signal periodicity, sir? Simply take GCD of the given frequencies. Either it is in continuous or discrete. Other than sinusoids are given means what we have done. Just draw the graph. From the graph, we can observe whether it is periodic or aperiodic, other than sinusoids. Of course, we have another classification that is called as deterministic and random signal. This is only for definitions, sir. Deterministic signal means either in mathematical or graphical form, we can represent either it is present instant, past instant, or future. We know the shape means that is deterministic. Random signal means before its occurrence, there exists some degree of uncertainty. Some degree of uncertainty. Like tossing of a coin, tossing of a die, thermal noise. We cannot predict exactly. Known shape deterministic, unknown shape random. The best example of deterministic signal is voice. Random signal is noise. Voice, noise. Writing the exam is deterministic. Getting the result is that you have to decide. Okay. It is only for definition, sir. No special significance for that word. So total 5 classification of signals we learned. First, we started with energy and power, which is used to measure the size or capacity. Second one is evenness, oddness to check symmetry, anti-symmetry. Then we checked causality, the signal which covers for positive time. Periodicity for harmonic concept. Last one is deterministic and random signal. So whatever we discussed till now is introduction to signals. Let us start the next topic, systems. We are having a concept called as a doublet derivative of impulse. At the end of the chapter, I will discuss it. Delta dash t, derivative of impulse is called as doublet, sir. At the end of the chapter, I am going to discuss it. Okay. Let us start the next topic. Systems. Simple way to define the word system is an operator that maps relation between input and output. It is an operator that maps relation between input and output. So it is some transformations are internal to the system, some modification is done. T for transformation. Input is also called as excitation, output response, or we can use the word cause and effect. All have similar meaning. An operator that maps relation between input and output is called as system. Internal to the system, some modification is done. When you have a public addressing system, what components we are using? Microphone is needed. First, our voice signal is converted to electrical signal. Then a voltage amplifier is needed that will amplify the voltage signal. Current amplifier is needed that provides power to drive our loudspeaker. Like that, there are multiple systems we need. So internal to the system, certain modification is done, sir, depending on the requirement. So if you take a continuous time system, we are denoting the input signal as xt, output as y of t. So y of t is a transformation of xt. We are modifying the input through the system block for getting some respect to output signal. Internal to the system, some modification is done, sir. Transformation means some change. Some change is done. Discrete case x and yn. Of course, in controls, our habituated symbols are R of t, C of t. R of t input, C of t output. But in signals, we clearly know R of t stands for ramp. To avoid that confusion, we are using xt, yt, sir. Actually, you study any subject, we are struggling only for 2 points, sir. 2 things are unknown for us. What are they? Input and system are known, get the output, that is called as system analysis. Input and system are known, get the output. Input and output are known, get the components of the system, that is called as synthesis. Getting the output is analysis, designing the system is synthesis. Getting the output is analysis, designing the system is synthesis. Of course, all 4 years BTech, we are doing only analysis. We know input and system, get the output. When you do MTech in a particular specialization, we are learning the opposite enjoyment. You will know input and output, you are designing the components of the system, that is called as synthesis, sir. What are the different ways of representing a given system? How a system can be represented, sir? One is direct way, like x square t, system is squarer. Another way, e power xt, system is an exponential operation. Okay. The other way, we may represent a differential equation or a difference equation. Instead of direct expression like this, we may go for differential or difference equations, sir. Or we may use the concept of transfer function model, open loop, closed loop. These words are used in controls. Transfer function model. Certain times we are using impulse response. Certain times we are using impulse response. Of course, that is our next chapter, convolution. If these 2 techniques fails, we may go for state space analysis. If the 2 techniques are failing, we are going for state space analysis. Depending on the requirement, any one mathematical model is used, sir. It may be a direct expression like this, differential or difference equation, transfer function, impulse response, state space. Probably most of you are aware, when you have first order differential equation, solving using mathematics, it is easy, particular integral complementary function. But when you have 4th order or 5th order, getting the solution in time domain is difficult. We need transform domain. That is what we are learning in the subject, sir. Whether you want to solve a given question by direct method, convolution approach, Fourier transform approach, Laplace transform approach, every chapter we are solving same problems. Only the technique. Every chapter we are solving same examples only, sir. Only the technique differs. Either we take a continuous system or a discrete system. There are 6 forms of systems which we have to learn, sir. Total 6 forms, out of which linearity, stability, invertibility concept. These systems we are studying only with amplitude. The word linearity, stability, invertibility. Other three systems like time invariance, causality, static or atomism, we are speaking only with time, sir. When you define a causal system, we will say present output, present input, purely with the time. Causal system means purely with time, present output, present input, like that, past input. But when we check stability of the system, we will speak with output amplitude and input amplitude. What, Pranali? Lower your hand. When you are saying stability concept, we will speak as output amplitude and input amplitude, sir. Be careful when you are using the word. Linearity means y-axis output amplitude, x-axis input amplitude. We don't bother about time under linearity. Okay? First, everyone get the clarity in that point. Okay, moving to next slide. What is the condition for linearity of a system, sir? What is the condition for linearity of a system? We should obey superposition principle. We should obey superposition principle. What is superposition theoretically? Sum of scaled input signal should produce a sum of scaled outputs. Superposition itself is combination of two conditions: additivity, other principle, scaling or homogeneity. What is additivity principle is x1t transformed to the output as y1t. This arrow mark indicates the system operation we are using. Another input signal x2t transformed to the output as y2t. In the same system, when you apply sum of inputs, if it produces sum of outputs, then we can say additivity is satisfied. Scaling is output due to scaled input must be equals to direct scaled outputs, where alpha need not be real. It may be complex also. Additivity theoretically is output due to sum of inputs must be equals to sum of individual outputs. Scaling condition is output due to scaled input. In the place of xt, we are substituting alpha xt. Output due to scaled input must be equals to direct scaled output. Of course, most of the fellows will use combined condition. Alpha x1t plus beta x2t should produce as alpha y1t plus beta y2t. That is called as superposition. Instead of checking individually, at a time also we can check it combinedly also. Normally in network subject, what we are doing, sir, under superposition theorem, finding the output due to voltage source, current source separately, then we are adding the answers or not. What is voltage and current source in signal subject? Just x1t, x2t. We are not using any specific word. Superposition itself is additivity and scaling. Don't feel superposition is separate, homogeneity is separate. That is wrong. Superposition itself indicates obeying additivity and scaling, sir. The arrow mark indicates the system operation we are using. So let us see few examples on linearity and non-linearity, sir. Suppose if you have taken xt into x of t minus 5, signal multiplied by its delay, is it linear or non-linear, sir? Signal multiplied by its delay. Come on. Without the delay, it is like yt equals to x square t. Without the delay, it is like yt equals to x square t. In general mathematics, y equals to x square is parabola or not. So instead of giving xt into xt, what I have given now? Xt into x of t minus 5, which is non-linear. Actually, we should check one of the principles, sir. If you want to check additivity, y1t is x1t into x1 of t minus 5. If I apply input as x2t, y2t is x2 of t into x2 of. So for checking additivity, xt is replaced as what, sir? x1t plus x2t multiplied by x1 of t minus 5 plus x2 of. It is like a plus b into c plus d. If you expand the product, it is generating 4 terms. Additivity is not satisfied, system is non-linear. Directly in the place of xt, if you substitute x1t plus x2t, it is generating 4 terms for us. But if you add these two, only 2 terms are there, sir. Additivity is not satisfied, system is non-linear. If you are unable to understand this way, I am taking a specific input for you. Assume first input as ut, second input as 2 ut, sir. First input as ut, second input as 2 ut. So first time, what is the output answer, sir? Ut into u of t minus 5 means when you multiply, both are covered after 5. Due to the second input, 2 ut into 2 u of t minus 5, answer becomes 4 into u of t minus 5. 2 2s are 4 there. What is x1t plus x2t, sir? When both inputs are added, answer becomes 3 times ut. Answer becomes, what is the output we should write now? 3 ut into 3 u of t minus 5, the answer becomes 9 times u of t minus 5. What is sum of these two? y1t plus y2t addition is 5 into u of t minus 5. But now we got 9 times u of t minus 5. So that is indicating additivity failed or not. System is non-linear. If you want, you can apply a specific input like ut, easy signal. If I change the same system as xt into cos phi t, now you think of. If I change the same system as xt into cos phi t, sir, now is it linear or non-linear? System is linear. It is a modulator. Every fellow can recognize it is looking like DSBSC, m of t into cos omega ct style. DSBSC is a linear modulation, sir. Y1t is x1t into cos. Y2 of t is x2 of t into cos, like that. Cos is a predefined signal for which no modification can be done, sir. DSBSC is a linear modulation. What is the difference in examples is, both examples we have done multiplication only, both examples. First time it is unknown signal product. If xt is unknown, of course shifted version also unknown. Whereas second time unknown signal is multiplied by a known signal. Cos phi t is a predefined signal, sir. So conclusion is what? Unknown signal product makes the system non-linear. Whenever you take unknown signal product, it makes the system which operation? Non-linear operation. In the second example, unknown signal is multiplied by predefined signal. Cos phi t is a predefined signal. Unknown signal product makes the system non-linear. Unknown signal product makes the system non-linear. Suppose we selected integrator, integral of x tau d tau. Integration is linear or non-linear? Yes, Omsri, correct. X of t can be any signal. What about an integrator, sir? Integration of sum of signals or integration of individual signals, it makes no difference. So 100% linear. Either you take integration of sum of signals or integration of individual signals, it makes no change in the answer. Linear. What about sample of xt, sir? Sampling operation is done with respect to time. That is not affecting our amplitude. Sampling means operation is done with respect to time, which is not affecting our amplitude. So what we can say, sir? Very good. Linear is the answer. When you pick the sample, only time index changes, amplitude as it is. It is linear, but time variant. It has a time dependency, so time variant. Sampling operation is depending on time. Amplitude is not affected. Output is a trigonometric function of input, sir. What you can say? Output is a trigonometric function of input. Trigonometric functions are non-linear. According to additivity, we want cos A plus B answer as cos A plus cos B, not possible. According to additivity, our expectation is like that. Even if you draw the graph, output amplitude versus input amplitude, sir. 0 input, output is 1. Everyone knows how to draw the graph. Our expected curve is straight line. Linear means we want straight line, this red signal. But it is showing non-linear graph. When you want to check the linearity, draw output amplitude versus input amplitude. If it is a definite integral or indefinite integral, it depends on that alekya. Whether it is definite integral or indefinite integral. Voltage across capacitor formula is what? 1 by C integral IT dt. You are calling that as linear system or not? Output is trigonometric function of input means non-linear. Suppose we have taken u of xt. Like ut, I have given u of xt. It can be written as 1 for xt greater than 0, 0 for xt less than 0. If I draw yt versus xt curves, for all positive inputs, output is constant 1. For negative inputs, output is 0. Non-linear. If you try to draw the graph, for xt greater than 0 means for all positive inputs, output is 1. Negative inputs, output 0. Not forming a straight line. Non-linear. Two xt plus 3. Two xt plus 3. What is the output due to scaled input? Alpha xt. Directly xt plus alpha xt we are substituting. Externally, what is the scaled outputs are alpha into yt means alpha into 2xt plus 3. That is 2 alpha xt plus 3 alpha. Here we have 3, here 3 alpha. The addition of constant makes the system non-linear. Addition of constant makes the system non-linear. Some fellows will call this system also as incrementally linear systems. That is also a correct word. Why the word incrementally linear is, for every change in the input, output is incremented by 1 unit, sir. For every change in the input, output is incremented by 3 units. If I take 2xt, it is directly passing through origin. 2xt plus 3 means every change in the input, output is incremented by 3 units. Without 3, it is linear only. With extra 3, it is called as incrementally linear system. In the exam, if they give the word incrementally linear for this expression, you should choose it. It is a correct word only. Otherwise, they will give non-linear, sir. Otherwise, they will give non-linear. We are adding a constant number indirectly means we are adding the initial condition that is present in the system. We are adding a constant number indirectly means we are adding initial condition that is present in the system, sir. Similarly, suppose we have taken modulus of xt. Now, sir, modulus of xt. Magnitude of positive or negative number becomes positive only, non-linear. What is the output due to scaled input? I am assuming alpha as -5. Directly xt plus alpha xt means 5 times mod xt. Externally, what is the scaled output, sir? -5 times mod xt. This result, they are not same, non-linear. Actually, yt versus xt graph, if you draw, for all positive inputs, output is positive. For all negative inputs, output is positive. It is forming V shape. It is forming V shape. Everyone, you are aware, magnitude means rectifier. Rectification is linear device or non-linear device, sir? Rectifier is a non-linear device. Magnitude we are taking means rectification. That is non-linear. Now you think of, in the system expression only hint is available. Directly in the system expression only hint is available, sir. When you draw yt versus xt graph now, what will happen? It is a straight line only for the range -1 to 1. After 1, constant amplitude of 10. Before -1, it is -10. Non-linear. After 1, 10, sir. Before -1, -10. Nagarjuna, correct. Present sample by past sample. X of n divided by x of n minus 1 means present sample by past sample. What you can say now, sir? Can you write a plus b by c plus d as a by c plus b by d? According to additivity, that is our expectation. That way of splitting is possible? No. So non-linear. We stated in the first bit, unknown signal product is non-linear. Now we have done unknown signal division. That is also non-linear. Unknown signal product non-linear, sir. Unknown signal division also non-linear. What about exponential operation 3 power xn? Exponential operation means automatically which operations are non-linear. Because what is our requirement? We want to write alpha power m plus n answer as alpha power m plus alpha power n. Not possible. Non-linear. Think of rounding. Rounding means taking the next integer value. When you have 4.8, it is rounded to 5 like that. Rounding operation is linear or non-linear, sir. Suppose we have chosen input amplitude like 2.3, 3.4 in this case. What are the output numbers, sir? 3 and 4 respectively. When both are added, it becomes 5.7 rounded to 6. Individual output addition 7, this is 6. Non-linear. Of course, quantizer is a non-linear device. Every fellow know it. We are doing quantization means indirectly what we are doing, sir? Rounding or truncation. In communication, what is the word we are using? Mid-read, mid-raise, quantizer. That is like a staircase waveform like this or not? Output versus input. So quantization operation is non-linear operation. Instead of rounding, some fellows will say that as seal. Take seal means highest integer. Truncation means floor. Taking the lowest integer is called as floor. Instead of rounding the word, what Shubham Agarwal? Instead of rounding the word, seal is used, sir. Instead of truncation, floor is used. They are also non-linear operation. क्या होगा रे? So whatever we are learning in other subjects, that I am writing as mathematical expression here. Okay. What about if you take system as complex conjugate, sir? System operation is complex conjugate. Now you respond. What, Fatima? Are you giving answer? What is that star means? System is complex conjugate, linear or non-linear? Very good. Here, additivity satisfied, second condition fails. Normally, for complex numbers, you are aware a plus b whole conjugate is taken as a conjugate plus b conjugate. Same thing is equally true for signals, sir. But scaling is failed. What is the output due to scaled input? Assume alpha like 3 plus j4. Xn place we are substituting 3 plus j4 xn conjugate. That is 3 minus j4 into x conjugate n. Externally, what is the scaled output? 3 plus j4 into x conjugate. We are not producing same result. Here we got 3 minus j4 into something. Here 3 plus j4 into. Don't ask a question if alpha is real number. Alpha need not be real. Alpha need not be real. It may be complex, sir. If the question is get the real part of xn, sir, get the real part of xn. Now what you can say? It is also non-linear. Check the same condition. What is the output due to 3 plus j4 into xn? So it is real part of xn plus alpha xn means 3 plus j4 into, that becomes 3 times real part of xn. Xn may be complex. Even it is real also, still it fails. Externally, what is alpha into yn? 3 plus j4 into real part of. Due to scaled input, we got this answer. Due to scaled output, this answer failed. Either it is real part or imaginary part or complex conjugate. In all cases, scaling fails. System is non-linear. Generally, to check linear system behavior, that is LTI system behavior, in subjects like controls, network signals, we are using the Baudelaire-Nyquist plot. Non-linear system behavior is checked by using a concept called as phase plane analysis. That is advanced subject optimal control theory, sir. When you learn that subject optimal control theory, you are going to have that graph, phase plane analysis graph. Of course, diode ideal condition linear, otherwise non-linear. That is generally used in EDC and LLR. Communication, we are using non-linear device. Generation of AM means first circuit we are learning is what? The generation of AM. Square law modulator, message plus carrier given to NLD, non-linear device or not. So don't have a wrong thought. Non-linear device means there is no significance. They have significance for mathematical convenience. We are modeling the systems as LTI systems. Okay. One question for you. If two non-linear systems are connected in series, is the overall system will be linear? We want to cascade two non-linear blocks. Whether the overall system is linear or not is my question. If two non-linear systems are connected in series, is the overall system will be linear? Maybe linear is the answer. The reason is, if I take one system as exponential non-linear, sir, followed by natural logarithm, that is also non-linear. Here input xt, output is e power xt, but final output is yt equals to xt identity system, that is simply linear. Of course, if you take the same system like this or exponential followed by squarer, still the combined operation is non-linear. So answer for that question is maybe linear. There is a chance of linear. Maybe linear. What you can say about their parallel connections are? Two non-linear systems connected in parallel. Parallel means addition. What we can say? In series case, there is a chance of linearity. If you take two systems, opposites are exponential, logarithm, square root, squarer, like that. What will happen in parallel case? Maybe linear here also. Because if you take one system like 2xt plus 3, Addition of constant can be treated as nonlinear. Another system like xt minus 3. After adding them, resultant output is 3xt, that can be linear. Individually they are non-linear, but combinedly linear or not. Sahiti, there is so much story. In speech signal processing, we are using a concept called as homomorphic signal processing. There we are using exponential followed by one digital filter, ln followed by another digital filter. They have practical significance. Certain times nonlinear systems are used to improve the dynamic range of a system. Okay, to improve the dynamic range. Your statement is correct. They are used to improve the dynamic range of the system. Actually, I have so much dizziness today. I'm on fasting. So I want to stop for today. I'm unable to continue. So much headache I'm getting. Till 7 o'clock only I planned today. Okay, that's all for today. Please excuse me for today. Tomorrow we'll have session from 5 to 9. Okay. Today, please excuse me. Tomorrow, I will take from 5 to 9, sir. That's all for today. Okay, bye everyone.